Imagine you want to be invisible, not on Instagram, in the universe. So you kill the lights. You whisper instead of shouting. You hide your signals. And then someone points a thermal camera at your face, and you realize you can't hide because life makes heat, and technology makes even more. Every machine is a trade. You get order, motion, computation, control, and you pay in waste heat. And here's the unsettling idea. If that's true for one machine, it's true for an entire civilization. So maybe the most important question isn't, where are the aliens? Maybe it's this: how much heat would we see if someone out there actually grew big? Imagine the Milky Way as a thermal image. Stars are the bright points. Technology is the glow that shouldn't be there. In 1964, a Soviet astronomer wrote down a short, simple scale. 3 steps: planet, star, galaxy. Not because he loved science fiction, because he needed something that physics is: measurable, universal, the Kardashev Scale. Here's how we're going to use it. First, we'll pin down where we actually are on the scale, right now. Then we climb through the 3 levels of civilization: planet, star, galaxy. And at every step, we'll look for the same thing. Not just what more energy lets you do, but what it forces you to become. In the next minutes, we're going to do something that's both comforting and terrifying. We're going to take the universe and hand it an electricity bill.
Because this isn't a story about bigger machines, it's a story about limits. But there's a twist. This scale doesn't measure intelligence, it measures power, how much energy a civilization can harness. So before we climb, we need a rule, a single universal way to judge those 3 levels. And that rule is what we're going to lay down right now.
Here's the rule. If you want to compare civilizations, you run into a problem. Culture isn't universal. Morality isn't universal. Biology probably isn't either. But physics? Physics is brutally fair. Whether you're made of carbon or something we haven't even imagined, if you want to do work, you need energy. At first, it's muscle. Then fire. Then wind and water. Then fossil fuels. Then electricity. And every time, the same thing happens. More energy means more possibilities, more cities, more machines, more control over your environment. And eventually, energy stops being just a tool. It becomes a measurement. Kardashev's move is simple. Don't define progress as an opinion. Define it as power output in watts. And build a ladder so large it almost feels ridiculous. And that raises the obvious question. Where do we land on that ladder? Not where it feels like we should be, where the numbers put us. This is the part that always surprises people, because everyone thinks we're advanced. We have nuclear reactors, satellites, AI. We have cities that glow from space at night. And that's only the light you can see. In infrared, we already look like a small, warm stain. Not because we're evil, but because energy always ends as heat. And still, we're not even type 1. Here's the ladder people like to draw. Type 1. Planetary energy under control. Type 2. Stellar energy under control. Type 3. Galactic energy under control. And below all of it, the part nobody brags about, is Type 0, where we live. Right now, we're roughly Type 0.72 something. That sounds close to 1. It isn't, because this scale isn't linear. It's a staircase of powers of 10. On that staircase, a little higher means a lot more energy. Humanity's average power use is on the order of approximately 20 terawatts. Type 1 is on the order of 10,000 terawatts. That's still only on the order of 5% of the sunlight Earth intercepts. That gap isn't a step, it's a cliff. That's not an upgrade. That's a different species of machine. And here's the first real tension point of this film.
If Type 1 is still that far away, even though we already look modern, then the Kardashev Scale might not be a ladder you simply climb. Maybe it's a series of bottlenecks. And the first bottleneck begins exactly where we already are: planetary control.
So what does Type 1 actually mean? Not we have lots of electricity. It means you can steer the energy flow of an entire planet so that weather, infrastructure, industry, agriculture, and security stop acting like separate systems and start acting like one operating system. A Type 1 planet wouldn't just be covered in solar panels. It would be stable. It would have what we still struggle to build: resilience at scale. Storage that doesn't blink, efficiency that feels unfair, and coordination that holds under stress. And here's the catch, the thing that connects this episode to your whole series. Type 1 is not primarily a technology problem. It's a systems problem. Because at a certain point, energy isn't just something you produce. It's something you distribute, secure, account for, justify. And the more you optimize, the more fragile everything becomes. You've seen it in perfect systems. When everything runs just in time, one just too late becomes a chain reaction. Type 1 sounds like control, but every upgrade comes with a new failure mode. Complexity, hunger, and coordination breaking at scale. Critical catch. You don't reach Type 1 without growing up. Not morally as a slogan, technically and socially as reality. You need a civilization that can plan long-term, that builds buffers, that doesn't set the whole network on fire every time conflict erupts. And if that fails, then Type 1 isn't the first step on a ladder. Type 1 is a filter.
And now it gets bigger. Because if you do survive Type 1, the next step becomes almost inevitable. You look up and you ask, why settle for one planet when a star is burning above you? That's a huge outlet.
Type 2 is the famous step because it has an image. The Dyson sphere. And that phrase tells you everything. You stop scraping for energy on your planet, and you start tapping a star. That's 10 billion times a Type 1 world. Not symbolically, not poetically, as infrastructure. And however it's built, sphere, ring, swarm, something in between, the idea is the same. You capture starlight. You turn cosmic weather into power. It sounds like God-level engineering, but physics stays brutally fair. You can use energy, but you can't make it vanish. Almost all of it ends as heat, and heat has to go somewhere. So a Type 2 system wouldn't just dim a star. It would glow in infrared, likely as a strong mid to far infrared excess, like a gigantic space heater. And this is the moment the story tilts from science fiction into something uncomfortable. Because we can search for waste heat, not for messages, for fingerprints, for an excess of warmth that simply doesn't look natural. It's boring, and that's exactly why it's credible. A civilization can lie. Thermodynamics doesn't lie. Critical catch. The universe already glows in infrared. Dust can fake it. Young stars can fake it. Nature can wear the mask of technology. So even if you find something, you don't have proof. You have a lead. And for Kardashev, that's enough. Because this scale never promised we would find aliens. It only promised this: if someone grows large enough, physics will leak.
And now comes the step where the ladder starts to tip over. If Type 2 can already become visible, how could Type 3, an entire galaxy, ever stay quiet?
Oh.
Because at that point, the universe should be, impossibly loud.
Type 3 is where human intuition breaks. We picture it like pop culture. Galactic civilization equals ships everywhere. That's a story. Physics is simpler. A Type 3 civilization has access to the energy of an entire galaxy. For the Milky Way, that's about a 1 with 37 zeros. In other words, hundreds of billions of suns added together. And if it uses even a meaningful fraction of that, it has to dump that energy again, as heat. Which means a Type 3 galaxy should look different from a normal one. Not subtly, not maybe. It should look like an object radiating too much infrared for the amount of starlight you see. And here's the cold reality. When astronomers look for galactic heat monsters, they don't find anything unambiguous. What we have are ceilings, boundaries that say, if they're out there, they're rare or quiet or strange. If Type 3 civilizations exist, they're rare, or they work in ways we don't expect. And this is where we have to ask an honest, uncomfortable question. Maybe our baseline picture is wrong. Maybe the Kardashev Scale isn't a career ladder. Maybe it's a mistake. Or a misunderstanding of what advanced really means.
What if we've been measuring the wrong thing, and that's why the sky looks quiet? And now comes the twist that carries the film to the end. What if the most advanced civilizations don't get hotter, but colder?
We carry an unspoken assumption. Progress equals more energy consumption. That's true for many phases, but look at real technological history. The best machines aren't the ones that burn the most. They're the ones that do the most with the least. Efficiency is another kind of power. Now, scale that idea up. very far up. A truly advanced civilization might ask, why tap an entire star if I can achieve my goals with a tiny fraction? And here it becomes almost philosophical, but still physics. If your real goal is information, computation, simulation, consciousness, AI, then energy isn't the only thing that matters. Temperature matters, because every real computation produces entropy, and entropy becomes heat. And the colder your environment is, the easier it is to dump heat away. Colder space helps, but you pay for it in surface area, which leads to a disturbingly plausible idea. An extremely advanced civilization might choose to relocate, not closer to the star, farther out, into the cold. Because out there, computation is easier, cheaper, longer. And suddenly, the Kardashev scale looks different, not as always bigger, but as two strategies. Strategy A, you grow massive, you grow bright, you become visible. Strategy B, you grow efficient, you grow cold, you become hard to find. And if that's true, it explains something without dropping us back into the usual Fermi cliché. Maybe the universe isn't empty. Maybe it's just not spectacular. Maybe the sky isn't full of empires, but full of civilizations that learned one thing. The dangerous phase is the loud phase. Because if you run hot, you're seen. And if you're seen, you're part of a game whose rules we don't know. Not hello or silence. Something colder, heat, or disappear. And right here, the Kardashev scale turns into a warning for us. Because we're entering the phase where we become planetary. And planetary means we become measurable. Not just by radio, by our impact on the planet itself.
So what do we do with this ladder? It's tempting to read it like a game. Level up, more power. But that's the child's version. The grown-up version is this. Every level is a risk upgrade, because every level makes you more dependent. On stability, on control, on cooperation, on error-free systems. And we've already seen in this series how civilizations end. Not with a bang, but because systems become too complex, too hungry, too tightly tuned, too uncooperative. So the Kardashev scale stops being science fiction spectacle. It becomes a mirror. It asks, if we want to become Type 1, can we also avoid breaking on Type 1 problems? And here's the sentence that should stick. Kardashev doesn't measure intelligence. Kardashev measures throughput. Or, harder, it measures the size of your engine, not whether you have a steering wheel. And maybe that's exactly why we don't see clear Type 3 signatures out there. Because a huge engine without a steering wheel doesn't last. Which leaves us with one final nasty question. What if the highest type isn't the one that uses the most energy, but the one that stays stable the longest? Maybe the real scale isn't 1, 2, 3. Maybe it's 0.7, and then the step most civilizations fail. 1.0, but sustainable. And if we're honest, that's the most thrilling future of all. Not because it's galactic, because it's possible.
So where are we? On a scale that feels like science fiction and suddenly reads like the present. And here's the question, seriously. If you were designing a civilization to last, would you choose to get bigger or get colder? Tell me why in the comments. Because if the Kardashev scale shows us anything, it's this. In the universe, power isn't only what you can do, it's what you can afford without burning yourself alive.
And for your personal level up on a scale, like, subscribe, and continue the Cosmic Fate series with the episode in the bottom left.